Something I see very often is bad use of proportionality, incorrect use of proportionality. Everybody wants to set up a proportion like this, cross multiply, etc. And that's a perfectly good thing to do as long as you're careful about it. That's a very common and important type of procedure, but you need to have a little better understanding of just what you're doing when you do this. Of course, first you learn the procedure, but then you learn to apply it correctly. Okay, so one way that this proportionality would often be set up is you'd put the 200 pounds over the 0.5 meters because, of course, 200 pounds corresponds to a side length of 5 meters. And then you put X, the weight that you're trying to find for the 0.8 meter square, over the 0.8 meters. Okay, now there are actually better ways to write this down, but I'll leave it to you to understand those rules. And then you solve for X. Now people cross multiply. Cross multiplication isn't even a rule. Multiply by the common denominator, or in this case, simply to find X, multiply through by the 0.8 meters, and of course you know that. You get this result, and I'm not even going to read it to you. It's very obvious why this works. And check my arithmetic, make sure it really does come out to 320 pounds. But 0.8 over 0.5 is 1.6. And 1.6 times 200 is 320, 2 times 16 is 32, etc. Don't reach for a calculator to do that, please. Okay. Now, that works okay if your two figures were this and this, because they would have the same height, if we look at it this way, but this width would be 0.8, whereas this is 0.5, so this would clearly have 0.8 over 0.5 times the area, and giving it that proportion, 0.8 over 0.5 times the weight. Okay? Of course, we're implicitly assuming that this is concrete of uniform density and uniform thickness. Didn't write all that down. We don't want to get too formal here. We want to keep the ideas as clear as possible and fight my tendency to obscure them with side comments. Okay, so anyhow, we have this and this. That would work fine here, but that doesn't work for two squares for the obvious reason that if this is a square, it's going to be 0.8 meters down here. So you need to multiply by another 0.8 meters over 0.5 meters. And end up, in fact, multiplying then by the square of 0.8 meters over 0.5 meters. The correct proportionality, the correct way to understand this proportionality is that the weight is proportional to the square of the length of the side, because the weight is proportional to the area of that square, that chunk of concrete, okay? So that weight over weight would equal side length over side length squared. Now I could put subscripts weight 2 over weight 1, side length 2 over side length 1, and it might even be a good idea to do that. Put a 1 and a 2 there, because of course sometimes proportionalities are inverse, and we've got to keep track of how that works. Okay? But anyhow, that's the correct proportionality. So X over 200 pounds should be the square of 0.8 meters over 0.5 meters, both for the reason I alluded to up here and for the fact that that's just the way areas work, and it's easy to understand and prove that that's the case. So this is an application of a little more sophisticated fact that of proportionality, that the area is proportional to the square of linear dimension if two figures are geometrically similar. So that's what this note down here alludes to. Okay, so this is a very bad mistake, and it's a very common mistake to apply proportionality that doesn't apply. There's another bad procedure in the way this is written down. I'll leave it to you to understand what that is. What we have here with this graph that can be very quickly constructed. You should be able to construct a forpling graph in 10 seconds flat. Pick a point, assign coordinates to it, label it, and make estimates in another 30 seconds. Okay? And that's protection against bad proportionality. So, protection. . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . against this. Worth having.